This is the device for the counting circuit. It includes the NAND gate oscillator with its RC networks, all 4 chips, the 411, 417, 4510, and 4511, and the 7-segment display, which are taken from the prototype. The circuit's function stays the same, but the layout is more organized. Inputs like the push button, power switch, and mode switch are soldered directly to the board. The slide switch to control the numbers going forward or backwards in the count are also built in, allowing the direction to be changed using the 4510's up/down pin and clock input. One important change is the use of resistor networks instead of individual resistors. These compact components contain multiple resistors in one package and are mainly used for the 7-segment display. The circuit begins with the momentary push button input, also called a PBNO. When this button is not pressed, the circuit is open and no current flows. As soon as it is pressed, the circuit closes and sends voltage to the NAND gate oscillator, starting the entire counting process. The button is wired in a pull-up resistor configuration where one side of the button is connected to ground and the other is connected to an input pin with a resistor pulling the voltage up to supply level. When the button is open, the resistor keeps the input high. When pressed, the connection to ground brings the input low. The NAND gate oscillator is the core of the circuit. It generates a square wave signal, also known as a clock pulse, which drives the counting components. Without this repeating signal, the counters would never change, meaning the numbers would remain the same. The oscillator is built using a 411 NAND gate and a combination of resistors and capacitors that create a continuous on-off voltage pattern. These pulses provide the timing for when each number should appear on the display. That square wave signal is sent to a 417 decade counter. The 417 takes each pulse and advances it through 10 steps, one at a time. Each output pin goes high in sequence, counting from 0 to 9. The unused inputs like the reset and disabled pins are connected to ground or power so that the chip works correctly. The 4510 chip can count up or down in binary coded decimal. It counts from 0 to 9 using 4-bit binary output. It can be controlled to increase or decrease the count using its up/down pin. Its carry-in and carry-out pins are necessary for the dual-digit circuits as they allow for multiple 4510 chips to be connected together. When the first chip reaches 9, the carry-out pin sends a signal to the next chip's carry-in pin, triggering it to change the number. 4511 is a BCD to 7-segment driver chip. It takes the 4-bit binary output from the 4510 counter and decodes it into a format that can directly control a 7-segment display. Each combination of binary input corresponds to a decimal digit 0 through 9, and the 4511 translates this into the right pattern by sending signals through the display pins labeled A through G. These outputs are directly wired to the corresponding inputs on the 7-segment display. The output from the 4511 is sent to the 7-segment display. This display shows one digit at a time using 7 individual LEDs arranged in the shape of a number. The common cathode version is used where all cathodes are tied to ground. Each LED needs its own resistor to prevent each number from being different brightness. Finally, a second 4510 and 4511 chip were added to create a dual-digit counter, allowing the circuit to count from 0 to 99. The carry-out pin of the first 4510 connects to the carry-in of the second, so when the first digit rolls over from 9 to 0, the second digit increases by 1. Just like the first digit, the second 4510 sends its binary output to the 4511 decoder, which lights up the second 7-segment display.